Oh, all right. This must be a mistake, but I am streaming. It's 12:37 in the evening, so who knows? I may go to bed anytime. Let's see. I want to bring up chat. Um, all right, here we go. All right. Let's begin. So I'm working on my second file system library for the Swift programming language. It's a file system language, guys. The first thing I want to do is add the file size to the metadata. Okay. Oh, that's the wrong. Okay, so the first thing we need to do is now what is this? Let's do an experiment. Let's import. Oh, perfect. Import glibc, and then we do a. So metadata. Oh yeah, stat. Okay, and then what is the st size? Okay, and then we'll just run this. And I misspelled something apparently. It's an int. What about on Windows? I have a Windows virtual machine here. Oh, wait. You know what? Never mind. I'll just do int for now. Okay, so now that we have this, we'll just do. We'll just fulfill the complaints from the compiler. Status.st size, right? Okay. Let's write a small silly test. We'll just do this, and then right. This file is not empty, so it's self-evident. Oh, I guess that's okay. That's good. The reason I wanted this is because I'm planning to write a convenient method for reading data from a file. And knowing the size of the file would be very helpful there. So yeah, just a quick, you can see I already created the file here, and then midway through I'm like, oh wait, I need this first. So okay, add size to metadata. All right, what I'm going to do now is immediately check that branch out on my virtual machine and see how it works on Windows. Okay, so this is not an int. But it is a 32-bit. So we could use a int cast. Should work, right? Yeah, okay. So it didn't throw a exception, and it found the greater than 0 file size. So that's a good enough sign. So I'm gonna go and merge that now. Here we go. Auto merge. Now the big test here is whether macOS works. So pretty ironic that I'm testing on Linux and Windows, but not macOS. Okay, so now that we have the size, we can do some sensible things for read-write. Okay, so let's just work off that file. Let's see, I want to do... I want to see first... so this is my project. So let's go to. I want to see what Swift system exposes in terms of type aliases for C, because they do expose a certain amount of it. Where would it be? Oh, interesting. Never mind. It's time to put in another patch. I don't know if this is good enough, but for the 3 platforms I care about, it's good enough. Okay, let's go back to the investigation here. So there's things like, let me see. Platform car, for example. Okay, say interop, right? We have mode, we have car, we have platform car, encoding, that's it. But I remember they also expose read, right? Yeah, okay. So for read, we just dealing with a mutable raw buffer. We call system read. System read literally just calls read, which is this read, right? Yeah, that's why it's a raw buffer, because it's void star, unsafe raw buffer. So today you have to make open the file in the right mode, right? Make a buffer yourself and call this in Swift system, passing the buffer, mutable buffer, and then you cast the buffer to, well, I don't know, maybe there's some convenience there in Swift strings, but yeah, you need to convert the content of the buffer into a Swift string with the right encoding, and that's how you read a string from a file, right? So What is the appropriate cross-platform type to represent a byte? There's car, but I feel like it might not be the right thing. Let's see. Oh, I don't have Vim. That's awkward. Let me install VS Code here. VS Code. I guess we'll just do, yeah, it's a raw buffer pointer. So how would I get, wait. Okay, so I need to restart that. All right. Code. All right, so okay. All right, I'm just gonna create a random file here. Wait, actually, let me install Vim mode. Sorry for doing all this on the stream because I literally just set up this VM. Yeah, literally just now. So let's do Vim. I could do Swift, but I don't know how well Swift works on Windows. So, also, which one is the better one? This one, right? Or this one? Okay. Is there any settings I can do? Path of the folder containing the Swift executables. Okay. Default is looking for path, but does it work? Oh. Convert functional instance. I think it's working, guys. System. Let's try something. Some funky highlighting here, but okay. Let's see. Doesn't seem like it's working. The how do you do wrong which? I look this up every time. Which command for Windows? Which equivalent? Where? That's get command. Please, I need this for. Hello? Why would you do this? Oh, come on. Okay. Good enough. I can't tell if it's working. Let me try to build the index paths by building this thing, I guess. Okay. Now, what's this? Okay, I don't know. Maybe it's not working. What was I gonna do? Oh yeah, I was gonna test some stuffs. Let's just make a test file. Okay, and then here I'm gonna write import UCRT, and then type of what's interesting. What deals with strings or bytes? I mean, obviously read and wread, right? There's also wread, but I guess Swift test.swift could not load the Swift standard library. Swift C test.swift. No such blah 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 blah. Uh-huh. All right. Let's just throw this into a test. How about that? And whatever. Here we do ucrt.read. I don't know why the terminal is not working here. Oh no, it is working. Huh. int32 raw buffer pointer. Yeah, so it's not really helpful. It's the same as on Linux. Is there an API on Windows or in POSIX in general that deals with like bytes? I'm just wondering, like, what is the native size, byte size? I thought I fixed this. Okay. Distractions. Okay. So read write obviously is not the best. How about p-read? Okay, p-read is not a thing. Oh. I mean, write probably takes the raw buffer pointer as well. Interesting. It's not a buffer pointer. It's literally just a pointer. That's C for you. So I could go with my older research, right? Because I have my first library. In the first library, right, we have things like read bytes. And apparently on Windows we read cchar, and on Linux we read unsigned 8. And the way we do that is we read into a buffer. And buffer has the uninitialized capacity. And of course, we initialize the count. We assign the count. I mean, that's the way this is supposed to be used, right? So that apparently automatically is an unsigned integer. Well, let's just copy this and see what happens. Oops. Right. So some of these won't be the right thing to do, but that's okay. We can do self dot with platform string, right? Actually, yeah, with platform string. But I don't know, because I'm gonna use the packaged version of read. But read takes unsafe mutable raw buffer pointer. And you can have an offset. I like the offset. Okay, so I'll steal the offset idea. Read bytes from absolute offset, but we'll give it a default value. And then let's just write it from scratch. I'm gonna comment out this stuff, right? So the first thing you want to do is open a file. Open file descriptor.open. Self, right? And then the mode is read only. Of course, we'll throw here. Oh, we'll try here. And then we read from it. So now we need to create a mutable row buffer pointer. So before, right, I was, oh yeah, let's do the defer. This is interesting because if close throws, then we can't defer. We just have to call it by the end. Okay. Yeah, so one good extension to do is extension file descriptor, and then you need, I want to add something like I don't know what's the good name is, but maybe it's like while open, right? And then you take an action, run action, and then here you give the file descriptor, right? File descriptor, and then this one is throwing. Something like this. Oh. Okay, and oh wait, I guess this one has to take the mode, right? Oh wait, this should be path I think it's worth more if it's a if it's a path. Yeah. So we just forward everything else, right? So we have the mode, we have options, permissions, retry on interrupt, right? Now we have this open self mode. Oh, options. Right, this is throw, so that means this whole thing must throw instead of simply rethrow. That's not a big deal. But the whole reason I wanted this is so that you can do this. And then you just run the action here, right? I feel like this could be useful. Because here I can just do self, wait. Self while open, something like that. Now I have a file descriptor, and then I can do whatever, right? Oh, right. This will have to be generic results. So this is not void. Result. Okay. All right, so now you can safely just, I guess, forget the concern about closing your file descriptor. I feel like that's pretty good. I like this pattern. But unfortunately, I probably will have to, well, let's see. We have read bytes, into buffer, retry on interrupt. I'll have to take this as well. That's fine. But we are going to call this, right? We're gonna make a buffer and call it unsafe mutable buffer pointer. Let's see if there's an example of them using it. Raw buff. So they just literally allocate 100 bytes. Interesting. Super raw. That's not super ergonomic though. Yeah, that's why I added the size in the first place, right? Okay. We're gonna read only, and then for options, do I need anything? I don't need anything here, right? Read only, permissions, not really. Retry on interrupt, forward. Okay, and here, I mean, we could also just read the metadata. Metadata. And if the file doesn't exist here, we'll throw an error. Now we have the size of the metadata. And we can... Oh yeah, we can do if meta.filetype.is. I don't know. If it's file, if it's not file, we'll just return this. Guard, yeah. But deal with symlink, I guess, because symlink, you can argue that you can read stuff from it. I think you can read it as a plain file. Yeah. But now we know it's a file, we have the file size. Then we can make the array, right? It's interesting. It's interesting how they're not using the array trick. I guess they don't know the size, so they're just using alloc. But it's definitely array. This API is awesome. Unsafe uninitialized capacity meta.size, and then you get the buffer, right? And then you get a count that you need to initialize. But the beautiful thing is, yeah, the buffer, you don't know the type, but the beautiful thing is the POSIX API is supposed to give you the size right here, right? So you're supposed to do this, and that's that. But who the heck knows? fd.read. We don't need the feed here. We'll take the buffer, right? Cannot find size. Wait. So here you need to say into, I guess. Yeah, I don't really know what the Swift team is expected us to use here, because this is, I don't know, like, cannot convert value of unsafe mutable buffer pointer element to, yeah, of course. This is also not the right thing, right? Yeah, now I have to cast this unsigned mutable buffer to the raw buffer. Unsafe raw buffer pointer. Unsafe buffer pointer. Right. Looks like this is legal. I don't know, man. Like, you just read into this buffer. Even though I already handled the file size, right? It still feels pretty wrong just to hand a buffer without telling read how much you want. This feels a little icky. Yeah, compare that to the way I did it in my first library. This is, I'd argue this is way more natural, right? You find out the size of the file, right? And then you just create a buffer of known type, which is an unsigned int in this case, but it doesn't matter, right? And then you call this very good Swift API that gives you an uninitialized typed array. You use the POSIX API, which takes the feed, which you already have. You give it your buffer and a size. You're telling the POSIX, give me this much, no more, and no more, right? So you know this buffer is safe. And then the POSIX API tells you what it actually reads, which is capped by the size you give it. And then that is what you initialize your array with, right? So the size here is the capacity and the count here is its size. Everything's well orchestrated. Everything works well together. But like here, read is not taking the size. Oh, I see. They take the buffer count. I guess that's fine. That's actually okay. Unsigned raw buffer pointer. What's the problem here? Unsafe mutable raw buffer pointer. Unsafe mutable. Oh, okay. So that's that. So, well, I guess I have to also respect the offset here. So the capacity and stuff, request size should be the file size according to the system, file system, minus offset, right? That seems okay. And then instead of using meta.size, we use the request size. Int and int 64. Why is this int 64? I mean, this won't work on a 32-bit system, but I'm just gonna not say anything about that. Okay. So the interesting thing is like, we can't test read bytes until we have write bytes, and vice versa. So let's also do the write bytes. Again, let's consult the Swift system write type. Write takes a buffer. Also retry on interrupt. Okay. And then they call this guy called system write. System write is just calling the write. I guess write is a little more complex in that you can truncate or not, right? Let's look at my write. Write. We have create. Yeah, if you write to something, you could say, "Hey, error out" if you create if the file doesn't exist, or just create the file. If the file exists, you can say error out if it exists, or just overwrite it, right? And then there's the truncating problem where if you need to truncate, then you need to basically use this flag. Again, like this is very neat. I feel like the way I did it, I like it. I mean, unsurprisingly, right? You simply just like let user express their intent, and then it just maps to the POSIX flags pretty simply. Yeah, now I just have to make it work with. First of all, like I don't even know if this organization makes sense, right? So you definitely want to write something. Why is this a raw buffer, raw pointer? Oh, write actually calls p-write. That makes sense. Yeah, all of this is it wouldn't be a problem if it's operation on the file descriptor. It is only a problem, I say problem, it's just a matter of like you lack the information about the permissions, so you have to ask from users, right? This is a method on the path object. So I convert the bytes into a contiguous array. And then I take the pointer, right? And then I call write, which will take the pointer and pass it on to the p-write POSIX method. And I deliberately made this like a generic with a little bit of constraint so that you can be flexible. If you're, I believe the thing I'm working with the most, I try to work with the most is data from Foundation, which is collection of unsigned integer. But obviously, if you have the read bytes method, then you would get the same type, except it's an array instead of opaque collection here. And that would work with this as well. Unsurprisingly, I like the stuff I designed. But now I need to redesign it so that it works with Swift systems. I think the generic stuff still makes sense, but now I'm just reevaluating reevaluating this. Let's see if I want to write if I want to do a write, then I know I'm not reading, right? So I don't need to express the file mode. It's gonna be write only, but I may have to take an open option unless I pick a set of defaults, right? Yeah, I have to think about it, whether I'm appending or not, whether I'm creating or not, truncating or not. So I may just ask the user to, well, I'll come up with the default and then ask the user to specify it further. Permission is also something that I can ask user for. This I can default to. Yeah, it's doable. It's not as bad as I think. So I also want to take some of this, right? By this, I mean like the generic thing. I really like that. So this and this, I guess, will have to become more granular. I mean, that just means you have to learn the POSIX crap, like what means what. Like you have to know the semantics of like combinations about the create, append, truncate, all that stuff. What if the default is like, I will create it for you if you don't tell me what to do, right? That makes sense. Yeah. But I do need to take all of this. And then eventually we'll have to call the write method here. Takes the raw buffer pointer, that's fine. Okay. So it's gonna be something like this. We're gonna do write. Is it write only? Retry. Yeah, this is something I need to deal with as well. So what is the sensible default, right? The sensible default, let's say I want to create, not append for sure. And the permissions. What about the permissions? Again, it all comes down to system, right? I guess POSIX just picks a permission for you. Oh, no. Oh, the permission is associated with the file descriptor, so you don't actually see it here. So there's a default open option, I guess. Wait, it's not initialized here. Then where is it? Seek origin. Where's the default value for open option? Okay, anyways. Yeah, we can test it. Okay. Instead of getting stuck here. All right, so we want to create for sure. We don't want to append. Do we want to truncate? I feel like truncate is the best because if you're calling file path.write, right? Usually it's unexpected that if you see you have 20 bytes in the existing file, you write 10 bytes, and then you open the file, you see 20 bytes, the first bytes being the thing you just wrote, and the last 10 bytes being the original 10 bytes, right? That's very surprising. So you don't want to do that. Yeah, so you want to truncate for sure by default. Okay, we need to document the shit out of this one. And then the file permission, I'll just keep it unspecified for now. But we need to definitely pass on the options. Well, open options, right? Okay. All right, so we have our good old file descriptor, and we have write. Oh, write all. Oh, yeah. We can also write to absolute offset. Do I want to do that? That would imply the default shouldn't be truncate, right? Write all. Let's look at write all before I go too far. What is the intention behind this? Okay, takes a sequence. Good sign. Writes a sequence of bytes to the current offset and then updates the offset. Grammar. Either writes the entire contents of sequence or throw an error if only part of the content was written. So how does that work? They take the raw buffer pointer, they call write with rebasing, and then there's a error handling. I'm guessing this is the return value of bytes. Oh, this is write all. Okay. They take the pointer, they call write. Oh, this is writing it while index is smaller than the count. Right. So they're writing it one chunk at a time, right? And they're rebasing the they're moving the pointer forward to the next chunk, to the start of next chunk. That's interesting. And that write is one of these, right? I'll save raw buffer pointer. That's line 254. And on line 288, there's also another version. This one calls p-write. Yeah, this one takes the offset. Pretty interesting. I guess what I want to call here is write all. And because I have bytes, I can even make this a sequence as well, even though, I don't know. So here I can literally just pass bytes to it. Write all. And nothing else. Wait, what about retry on interrupt? Retry on interrupt is true. That's cool. That makes sense, right? If you want to write everything, you retry on interrupt. Well, no, because I still need to open the file descriptor, so I still need that. Okay. I guess I don't really need to return anything. Cool. So now I have a write. We can write, try to make a simple thing, simple file here. I wonder. Obviously, our parameter would be a string, right? So we can do func write. What do I have here? We have write bytes and write, and then we take the string and the encoding. That makes total sense. Yeah, let's do that. So we have this. It still throws, and then it will have everything else like so. And then it calls our public method. We want to encode our string to the encoder, to the encoding. Wait, how does encoding work? Oh, you can just write it like this. Okay. Encoding type where cool. Can I give it a default? All right, fine. Oh, what is all this? Oh my God. Oh, encoding has its own code unit. That makes sense. If you want to write into a, let's say, UTF-16, then it's 16 wide. If it's 32, then it's 32 wide. That makes sense. So we first create a buffer with the unit. This doesn't seem right. That seems like a bug. And then we advance the buffer length unit by unit and append the data into it. Oh my God, this is ugly. And eventually we'll get the buffer. And then we take the buffer, we convert it back to bytes. And then we write the thing in. Oh boy. Let's see. If I make a Swift file, right? And here I say, hello, encode to utf16.self. Is that how you do that? No. How do you do that? Hold on. That seems like what you're supposed to do. Oh, because I'm using this API. Wait, how are you supposed to use this? Not here. Swift string code 2. String encoding, that's not what I wanted. Encoder. Encoder is a protocol. We don't talk about what conforms to protocol apparently. Oh wait, this is encoder. This is about wait a minute, what? I see. We see string encoded as we got the pointer, right? And here I'm just gonna print the pointer. Typo. Let's do typo first. Just for the science, right? Yep, that's the code point for UTF-16. I can change this to 32, then we'll have a different code point. Okay. So we have a unsafe pointer of that. Right? We also need okay, let's just write this for real, right? We take this, we take this. Everything else is irrelevant for now. We're gonna close this up. And we will call it write hello encoding UTF, let's say 16, right? And here we'll do string with a string encoded as encoding. And then you have the pointer here. We need to get the size of the code unit. Memory layout.size of, yeah. Okay, so we have a pointer, right? What is the, it's unsafe, wait, it's unsafe pointer. Okay, cool. So unsafe pointer has a pointee, right? So we want to get the memory layout, I think is of value. Size of value. Yeah, it's fine. Memory layout. I think I can do this. Encoding dot code unit size of value. I think. Oh, UTF-16.self. Can't use that. Can I ignore this? All right. Pointee. Yeah, let's fatal error here, right? Hold on. I can't use encoding.code unit here. Feel like it's a thing. You can use memory as a source of information about type when allocating or binding memory using raw pointers. The following example is blah, blah, and blah. Wouldn't this give me the type of the size? I mean, the generic parameter of t? Instance whether requires encoding conforms to this. Oh. I'm dumb. Okay. Yep, so we know the size is 2 bytes. Okay, so we're gonna make a buffer, right? The buffer is encoding code unit, and then we need to reserve capacity. Oh, do I want to do it this way, or we can do it the other way with the uninitialized blah 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 blah? We have the size. And then I can do array the uninitialized on. Oops, where was it? Unsafe uninitial capacity, right? Oh, wait, hold on. I need to do this first. Just to verify. What was I doing here? So we have a length. We're doing it datum by datum, right? I don't know, man. This doesn't seem right. What is this length? Okay, let me ignore this and think about this from a first principle. We have a string. We've encoded the string into encoding. Now we're getting the buffer. Unfortunately, it's just a pointer, not a buffer pointer. So I need to manually calculate the length, which is not a big deal. Our goal is to convert this into write all. Let me take a look at the write all again. Write all takes a sequence and it dictates that the sequence is in bytes, right? Okay, so we need to convert our code points to bytes. So I have the unit size. I see. So we're literally just getting it to a point where the datum is no longer 0. At that point, we're done with writing the datum. Otherwise, this API with C string encoded as doesn't give us the string encoded as. Yeah, it's a null terminated sequence. Yeah, I don't know. So my concern is if I simply cast this pointer to a byte size, right? Would there be nulls in the middle? Let's say this is a uint 32. So each unit has 4 bytes in it. Would there be a 0 inside those 4 bytes, right? If there is a 0 inside those 4 bytes and I cast this whole thing into a byte array, that means like the bytes can terminate, the string, quote unquote, C string can terminate right there. So is this really the only way to do it? It's really unfortunate that this is a pointer. If the body has a return value, is also the value, target encoding, return value. Any discussion pointer. Yeah. That's a weird use case. Let's look at whether how others uses it. Language Swift with C string coded as. Yeah, so this is just encoding to Windows. That's fine. That's fine. That's fine. Yep. Yeah, most of the use cases is just encoding to a to Windows points, which is yeah, everybody uses this to deal with Windows. But if you deal with Windows, you don't have to worry about. Well, actually, it is interesting. Oh, if you deal with Windows and you call the U16 16-byte wide car sized Windows APIs, then the null terminated string is perfect for it. I see. So no one is really dealing with data. They're dealing with data suitable for Win32 APIs. That's literally everything on GitHub. Crazy. Okay, so no one is really using it the way I am using it. Maybe I don't vendor this API at all, right? Maybe this API is just not that interesting. Yeah. So instead, we fix the encoding. You gotta be kidding me. This is an int. Oh my god. Why? Okay. We deal with this plenty of times, right? With memory. Let's take a. I think this is how you do it. Oops. It's a pretty bad way to do it, but here, for example, this is a tuple. And I'm casting it into an array of this. And that's how you use it. With memory rebound to unsigned int 8.self capacity 1 pointer 2, or let's call it signed pointer. Unsigned pointer. You don't see this type of Swift every day. Signed pointer. And we're trying everywhere. Here is unsigned pointer. We should have the right type. Okay. Whoo, finally. Look at this dance. Okay, so now we finally have a write method that just hardcore write UTF-8 strings, which I think is sensible as a convenient method, right? We let user convert, specify the options and permissions if they want to, and the corresponding option for retry when opening the file descriptor. We take our string, just take its UTF-8 bytes. Unfortunately, Swift gave us signed integer as the representation for string bytes. We rebound it to the unsigned integer pointer to satisfy the compiler, and then we use the write-all method. Then we create the buffer pointer, knowing the correct amount of UTF-8 units is the UTF-8 view count. So we make a buffer pointer, and at which point we have all the correct type and value in our variable. to feed to system. It's a really strange. I understand why they chose buffer pointer. I guess buffer pointer is less likely to get out of sync in terms of size and the content of the buffer, or more precisely, like the semantic is like it's unsafe anyways, but it's like on user to make sure that the things are in sync. And then you pass it on as one singular piece of information to this write all method. So that's why write all works this way. You know what? It's fine. It's fine. I'm gonna write some very simple tests. Oh, what's this? Let's write some very simple tests. Test simple read write UTF-8 string. Turns out I still need to write one more thing to satisfy this. Let's do bytes. How about that? Okay, and let's get some bytes. uint8 bytes. Let's do 1, 2, 3, 4, 1. Okay, and then let's use a temporary directory with temporary directory. This is a technique that I use to write my test. I open a temporary directory and it will get closed and deleted by the end. And during, it will be the current working directory. And then we can simply say the target file is temp appending a.t it's fine. And then target.write, right? Have a write, right? Right, yeah. So we'll do create and truncate. Interrupt is all good. So I just give it the bytes. And that will write out the file, create the file, and all that good stuff. And then I guess we'll assert that target exists. Let's also assert false, that it didn't exist. We write it, now it should exist. Let's run this test first. Filter, read, test simple, read, write. Bytes. XCT. What? Oh. Target can throw. Okay, a big old backtrace. Create must be giving permissions. Perfect. So we need to give it a default permission. Okay. Owner write, owner read, other read, other write. I don't know. I feel like read, write. Let's do touch. Let's see what touch does, right? Touch. Oh. Touch gives us read, write, read, write, read. Perfect. I think that means read, write, group read, group write. Okay. Now we have a permission. Create must be given permission. Am I not passing on the permissions? I guess I'm not. Wait, what am I doing here? This can be simplified, right? I just call myself. We have the buffer. Now I can call self.write buffer. Yeah. Here I just call unsafe raw because this is generic. Wait. Can this work? Um, aha, this is the trick. You take the sequence, you convert to a contiguous array, and then you just get the bytes and write it. I like that. Unfortunately, that's not what's happening here. So I guess I'll just have to live with this. Okay. Okay, the test passed. That's a good sign. Now we also need to test the read part. Read bytes. Read bytes. Okay. Mission accomplished. Right? We specified a file. We made sure it didn't exist. We write the bytes, random amount of bytes into it. And then we make sure that the file now do exist. We read all the bytes from it. And then we compare the result of the read with our original bytes, making sure they're equal. That is beautiful. Beautiful. The only thing I still want to add is reading UTF-8 string, because that's obviously very useful, right? Because you essentially you read a file for one or two things, I guess, bytes and strings, right? Binary or string. Read UTF-8 string. I only want to Swift format unused arguments. I don't know what that is about, but I just want to copy the documentation. The documentation is wrong. Okay, so we read the bytes and then we convert it into a string, right? Read string. Oh, interesting. We have a read string and then we convert it into an arbitrary encoding. Here we take the bytes pointer, we bind it to the code unit. And then we decode the bytes into the encoding. That's cool. This is cool. Read string as a encoding, and then we read the UTF-8 string, which simply is self.readString. Self.readString as UTF-8. Cool. So let's also write a test for that. This time would be simple read write string, UTF-8 string. Then it's the same formula, except now the string is hello system. We use the same target, make sure it doesn't exist. We'll write UTF-8 S. Now we make sure it exists. We read UTF-8 string, read string, and then the write string should be equal to the original string. Okay, and that test also passed. Not surprising because it's simply just added encoding on top of the read write byte stuff. So that's really cool. Reading, writing stuff. Okay, I just need to add change log here. Add file pass read bytes file pass read string file path read UTF-8 string file path add method should I do a sublist? The following convenient method for reading, writing on a file path. Okay, now here we do a sublist. We have this, we have that, and that, and this. Okay, so we have read. All right, I guess I'll write out the whole thing. Read bytes. Wait, let me make sure this is used. Oh, it's not used. That's not good. From absolute offset. Okay. From absolute offset. Retry on interrupt. To be honest, I can eliminate this, right? That's fine. The default value is as good as not being there. Most people will never use it. Read string. As read UTF-8 string write bytes options permissions retry on inter. I feel like retry on interrupt is really low level. Wait, also this is not being used. Right buffer. Yeah, I'm gonna remove these. Yeah. Okay. Let's add a little bit of explanation. Read bytes from self. Read string encode read bytes and encode to a specified encode to string with specified encoding. Read bytes and encode to UTF-8 string. Write sequence of bytes to self. Write a string decoded as UTF-8, decoded with UTF-8. To self. Okay, good enough. 31. The trailing commas, man. Just let us write it, please. Okay, everything is passing. Let's add the last round of stuff. Let's check out a new branch. Read write. Oh, it already exists. Actually, let's do this. And then let's cherry pick that. Okay, so we have all the additions here. I still need to write the doc strings for some of it, but I'll do it when I feel like writing prose more. Right now I'm just very, very tired. So let's just push it up. Don't care what's up there. Let's see. Yeah. And then let's wake up our old Windows and test it. Give it a little test over there. What could go wrong? Everything should work just fine because we're using Swift systems directly this time, right? Yeah, everything works. Now the interesting part is macOS. I mean, macOS should work as well because again, we're using Swift system directly. So there shouldn't be like weird type mismatches, subtle type mismatches. So I guess we're good. Once this is passing, I'll probably end the stream. It's almost 3 for me. So yeah, if for some reason you're watching this, thank you very much. If you're watching this on YouTube, please sub. Twitch, please follow. Yeah. I promise I will be back. Maybe with some Rust next time. Maybe we'll continue more on Swift. Maybe we'll write some Python project. I do have a Python project I need to finish. You never know with me what you will get. Okay. That's